Hello and welcome to Amit's Tech Sessions. My name is Amit and I'm a software architect. In this session, I'll talk about a few software architecture patterns which are implemented quite often in software engineering, however, not talked about enough. Let's first understand what is an architectural pattern. So an architectural pattern provides you a mechanism to create building blocks to write a well-architected software. Architecture pattern defines a general reusable solution to a commonly occurring problem in software architecture within a given context. So this is the definition from Wikipedia. Now, if I try to break down this definition into a simpler definition, a software architecture pattern defines the high-level structure of a software system. So it outlines the fundamental components, their interactions, and the overall layout of a software system. And then this software architecture pattern can be reused to build multiple software or applications. For example, client server is a very common software architecture pattern which is used widely. Client server architecture pattern can be reused by many different software applications wherever it is fit for purpose or it is needed. Similarly, microservices is another example of architecture pattern which is used very widely. So let's talk about a pattern called scatter and gather. Scatter and gather is a pattern where a request is routed to a number of recipients. Each recipient is a processor, and each recipient processes the request which is coming from the requester and then aggregates the responses from all the processors into a single response and then sends it back to the requester. So this is a high-level overview of scatter and gather pattern. There are various technologies available to implement this pattern, such as Apache Camel, SQS, SNS, step functions in AWS, MuleSoft, etc. You can choose a technology which fits well for your purpose or for your use case. Let's talk about another pattern, eventual consistency and strong consistency. So while developing distributed systems, there is always a conversation around eventual consistency and strong consistency in distributed databases. So these two are the key patterns which are commonly used for different use cases. So let's assume that you have a distributed database running on a cluster with multiple nodes which are geographically distributed. So what is eventual consistency? When you write the data to a cluster, eventual consistency is a model that guarantees that updates will propagate through the system and eventually will be applied to all the nodes given enough time. In other words, if no new updates are made to a particular data item, eventually all nodes will converge on the same value for that item. So eventual consistency provides you a high availability model even if other nodes are down. They will eventually be in sync at some point. It also provides a lower latency for write operations. This pattern is not suitable for all type of systems. For example, systems that require strict consistency, such as financial systems, may be unable to tolerate eventual consistency. So what is strong consistency? Strong consistency guarantees that each read operation would respond with the latest write operations result, regardless of the node on which the read operation is executed. The aim of strong consistency is to provide higher level of consistency. Strong consistency ensures that all the nodes in the cluster would see the same data without any temporary inconsistencies. Strong consistency is absolutely expensive to achieve because it comes at the cost of more communication and coordination within the nodes to maintain that consistency. Now let's talk about micro frontends. So in recent times, you have seen that microservices have gained a lot of popularity over the years with many organizations using this architecture style to avoid all the drawbacks of monolith systems. Microservices style is applied to backend services or server-side services. But wait, what about front ends? Well, let's say you want to develop a web application. A web application can have both front end and back end. So we also need to think about decomposing the front end monolith into smaller, simpler components. And that's where micro front ends come into the play. As per Martin Fowler, micro front end is an architectural style where independently deliverable front end applications are composed into a greater whole. So micro front end have many benefits similar to microservices architecture. You can have independent people or teams who can work on smaller front end components and take ownership of that. You also get smaller, more cohesive and maintainable code base with micro front ends. Now let's talk about an architectural pattern on the data side. So you probably hear terms like microservices orchestration, container orchestration, etc. on a regular basis in tech discussions. However, do you hear a term called data orchestration? Probably no, right? So what is data orchestration? Data orchestration is a modern approach to business intelligence. It is a process of moving siloed data from multiple data sources into a centralized repository where it can be combined, cleaned, and enriched, and then it is made available for analytics or for any other different technology systems. Why do organizations need data orchestration? Since data orchestration puts the refined data at a centralized place, it allows organizations to make informed decisions based on the analysis of that refined data. Organizations who do use data orchestration and practice data-driven decision making, they term themselves as data-driven organizations. Data orchestration allows organizations to eliminate data silos and helps them in acquiring real-time insights from the data. And there are various tools and technologies available to achieve data orchestration, such as Apache Airflow, Metaflow, etc. That's all I have for this video. I hope this was useful. If you would like to connect with me on LinkedIn or Medium, there are QR codes up on the screen. Thank you very much.